Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Sum-dex-ku, and it's by Morse JB. And here are the rules. We have normal Sudoku rules apply. Place the digits 1 through 9 such that each digit appears exactly once in each row, column, and box. We have region sum lines, where blue lines are divided into segments by box borders. Each segment of the line has the same sum, and different lines may have different segment sums. And also, index lines. All blue region sum lines are also index lines, where starting from, so region sum lines is an example. These two digits must equal the same as these three, which must equal the same as these three. These two digits must equal the same as this digit, which equals the same as these two digits. Because these are separate segments, because the box borders divides the line into separate segments. So this is a separate segment than this one. We also know all region sum lines are index lines, where starting from the blue diamond, a digit in the nth position indicates the index on the line where the digit n appears. So, for example, if this digit were an 8, that would say that the 1 has to be in the 8th position, right? Because n here is 1, because it's in the first position. And the 8 signifies where the 1 is. So that would be 1, 2, 3, 4, 5, 6, 7, 8. Therefore, the 1 would have to be in this position. And the index line is never larger than... the digits on the index line are never larger than the index line's length, right? Because it doesn't make any sense for this to be 6, because there is no 6th position that the 1 can be on. So that's a... well, it's just basically, it's sort of baked into the rules. You can't have an index into a nothingness, right? So this can never be 6, because this would be basically, where is the 1? There's no 6th position on this line. Anyways, that's how index lines works. And then finally, we have crop key dots, specifically white crop key dots, where cells separated by a white dot must be sequential or consecutive. Not all white dots are given. So for example, if this were a 6, this would have to be 5 or 7 to make sure that these digits add up to, are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the one that pops to my mind is these 5 length index/region sum lines. The most these could be is 5, and therefore the largest digit has to be the single digit by itself. So this is a 5 and this is a 5. These digits must add up to 5, so these two must add up to 5 and these two must add up to 5. Therefore this must be 1, 2, 3, and 4, because those are the only digits that add up to 5. Similarly, these are 1 through 4 and these are 1 through 4 also. 5, this is, with the 5 being here, that's saying 5 is in the 3 is in the 5th position. So this must be 3, and this must be 3. Same with this one, right? So 3 and 2 add up to 5. The 2 says that in being 4th means that the 4th has to be in the 2nd position, and this must be 1. 3 and 2 is here. Same thing. This is 4, and this is 1. Okay. We know... so we have digits from 1 through 8 here. That adds up to 36, because all 9 digits add up to 45. 45 minus 9 is 36. So 36 divided by 12, or 3, is 12. So these 2 digits must add up to 12. These 3 must add up to 12, and these 3 must add up to 12. Well, 2 can never be a digit that adds up to 12 by itself. Sorry, with a single digit, because that would be 2 and 10. This could be 3 and 9, except that this index line is 8 in length. So you can't have a 9 here. So it's either 4, 8, or 5, 7 here. So it could be 4 and 8, if that's 4 and 8, or 5 and 7. We know 2 can't be any of these cells here, and 2 can't be here, so 2 has to be one of these two. So 2 is either in the 7th or 8th position. So that means this is 7 or 8, which forces 1 to be in the 4th or 5th position. So 1 has to be one of these digits here. And 2 we know is one of these two. 3 cannot be in 4, 5, and 6, so 3 has to also be here. So 3 is one of these two, which means it's in the 6th or 8th position. So this has to be 6 or 8. We know in this segment, it has to be 2 and 3, plus another digit to add up to 12. Well, 2 and 3 add up to 5, so it must be with 7. So this has to be a 2, 3, and 7. Obviously, this can't be 2, this can't be 3. Since this is 2, 3, 7, this cannot be 7 on the index line because a 7 is in, well, 7 can only be 2 or 7. So that means this is 7, which makes this 8. This is 3, this is 2. Right, 8 has to be here. That means 4 has to be there to add up to 12. This can't be 8 anymore, so this is 6. The 1 is in the 4th position, so this is 1, and that makes this a 5 to add up to 12. And so the reason why we know all this is that the index lines, where can each digit be, right? You can't have repeats on the index line. Sorry, I didn't explain this very clearly. On an index line, you can only have the digits singly, right? And they can only appear once, essentially. So you have all the digits from 1 through 8 on an index line. And the reason is because if this is, like, for example, a 1, or say this is example a 6, that's saying that 6 has to be in the first position, right? But if we try to have a 1 anywhere else, that would say that that digit has to be in the first position, but we already have a 6 there. Therefore, that's not possible to have another 1 in that position. Or let's just use the one digit we have. We have 4. Say this is 4. That makes 1 has to be in the 4th position. If we had another 1 in this index line, that would mean, say we had a 1 here. That would mean 7 would also have to be in the first position, which is not allowed because you can only have one digit in each cell. So that's the reason why we know that each digit on an index line is unique. So these digits have to be 6, 7, 8, 9 in the rest of column 6. This can't be 6, this can't be 8. This digit must be that, so this is 1, 2, 3, 4, 5, 6, 7, 8th position. So 8 on here must be either in the 6th, 7th, or 9th position. So the 8 on this index line is one of those 3, which eliminates 8 here. This digit cannot be 3, 5, or 6. So it could be 1, 2, 4, 7, 8, and 9. That means 1 could be in the first position, 2nd position, 4th position. So 1 could be one of these two, 4 or 7, but it cannot really be 8 because 8 is one of those 3, or it's 9. So 1 is one of those. Okay. 2, 4, okay, these 3 digits add up to what these 4 digits add up to, which is what these 2 digits add up to for the region sum line. And it's 9 in length, so it must add up to 45. So, these 2 digits must add up to 45. Therefore, it's 6, 9, and 8, right? Because to add up to 15, it's either 6 and 9, or it's 7 and 8. Well, that makes a 6, 7, 8, 9 quadruplet in this box, which eliminates 6, 7, 8, 9 in the rest of the box. Therefore, the rest of the box must be 1, 2, 3, 4, 5, and neither of these can be 1, 2, or 3. So this must be 4, 5, which forces 1, 2, and 3 to be here. Anyways, 8 can be any of these. 9 can be in 9, 8, or 6. So all of these are 9, which they all see this cell. So this can never be 9. This is 6 or 7. Since this is 6 or 7, one of 6 or 7 has to be here. This can't be 6 or 7. Therefore, 8 or 9 is here. If this is 8, that would say 9 has to be in the 8th position. But we know to add up to 15, this would have to be 7. So this would be a contradiction. Therefore, this can never be 8. This can't be 7, which means this is a 6-9 pair. Well, 9, if 9 were in the 6th spot, this being forcing this to be 6, it could not be in the 8th spot. So this would not work. So this has to be 9, which makes this 6, which makes this 7, which makes that 8. 8 is in the 6th spot, so this is 8. 8 cannot be here. 1 cannot be in the 9th spot anymore. What is this digit? 7 can not be 6, 8, or 9. It could be 1 through 5. Actually, 1 through 6 here. No, 1 through 5 and then 7, but 7 can't be here. So it could be 1, 2, no 3, could be 4, no 5 or 6, no 7, 8, or 9. So 7 has to be in the 1st, the 2nd, or the 4th spot. Well, it can't be in the 2nd, so that means 7 has to be one of these two. Because the 7 in the column eliminates the 7 in the 2nd spot. These digits are 1 through 5 plus 7. And obviously 7 can't be here, 7 can't be here. 2 cannot be here. That means 2 can only be in the 1st, the 2nd, and the 5th spot. 4 could be in 1st, 3rd, 4th, 5th, and 7th. That works. 5 cannot be in the 1st spot. Could be in 2nd, 3rd, 4th, or 5th. 3 cannot be in the 1st spot. It can only be in 3rd, 4th, or 5th here. Okay. Okay. What the remaining digits in column 4 are 4, 7, 8, 9. And 4 cannot be here because of the 4 in the box. And this can't be 7. Where is the 4 in column 4? It has to be one of those two cells, which eliminates 4 here. So this must be 7, 8, or 9. This 7 and 8 eliminates 7, 8 here. So this is 9, which means 9 cannot be any of these. Where is the 9 in column 4? It has to be one of those two. That leaves 6, 7, 8 here. And 6 has to be one of these two. The 4 here eliminates 4 here, so that's 1. That means that 7 has to be in the 1st spot. So this is 7, which eliminates 7 here, so that's 8, which means this can't be 8. These can't be 8. This 4, 7 pair eliminates 4 and 7 in the rest of the column. This becomes an 8 and 9 pair. This becomes a 6, 7 pair. 1 and 7 can no longer be on the index line because of the uniqueness. 2 is either 2 and 5. 5 can be any of these. The rest of row 4 must be 1 through 5. This can't be 4. This can't be 4. This can't be 1. Since neither of these can be 4, 5 can no longer be here, because 5 can only be consecutive with 4 and 6. 6 is already taken in the column, and 4 is eliminated by the 4s in both columns. Therefore, this is either 1 and 2 or 2 and 3 to be consecutive. They both require 2, so that eliminates 2 from the rest of the row. This can't be 2. This can't be 2 either, so this is 5. That's saying 2 is in the 5th position on the index line, so this is 2, which makes this a 3-4 pair. This 5 eliminates 5 here. If this were 1, this would have to be 2 here, but we already have a 2 in that row, so this cannot be 1. Therefore, where we have a 3-4, 3-4 pair in row 4, which eliminates 3 and 4 in the rest of the row, this can't be 3, this is 2, this can't be 3 or 4 or 2, so that's 1. So this is 3 or 4. If it's 3, this has to be 4, because it can't be 2, because of the 2 in the row, but it can't be 4 because of this 4. Therefore, this can't be 3. This is a 4, which makes this 3, which makes that a 4. The 4 eliminates 4 here, so it's 5 and 4. The 4 can be next to 3 or 5, but the 5 in the row eliminates the 5, so this is 3. The 3 eliminates 3 here, so that's 1. This can't be 1, and this can't be 1 here. 3 is not going to be consecutive because there's already in this box, because the 2 and the 4 are already here. 3 can't be here, 3 can't be here, 3 can't be here, 3 must be here. We have 5, 6, 7, 8, and 9 left in the box. 5 cannot be either of these. 5 has to be with a 6. So either this is 5, 6, or this is 5, 6. So this can never be 6. Well, it could be 6 here. No, 5 is always with the 6 here. 8 cannot be here. This can no longer be 9 here. 5 must be consecutive with the 6 no matter what, because it can't be consecutive with 4, and it has to be consecutive with a digit because it's next to a white crop key dot. So 5 is always next to 6. Therefore, this cannot be 6, 7. It can't be 9. So this has to be 5 and 6 then. This is 5 and 6. That eliminates 5 and 6 in the rest of the box. If this were 8, that would force this to be 7, 9, which is not consecutive. So this must be an 8 here, and this can't be 8. So one of these is an 8. What else are we looking? This is just the rest of this is just Sudoku. So this can't be, we are missing a 7 and a 9 in row 3. This can't be 7 because of the 7 in the column. So this is 9. This is 7. That eliminates 7 here. In row 8, we're missing 2, 6, 8, 9, but 2 can't be here because of 2 in the column. 2 can't be here because of 2 in the box, and this can't be 2 because of 2 in the box. So where can the 2 be? It has to be here. The rest are 6, 8, and 9. In column 3, we are missing 2, 3, 7, and 9. 3 and 7 cannot be here, therefore this becomes a 2, 9 pair. And the 9 in the row 2 eliminates 9 here. So this is 2, this is 9. The 2 eliminates 2 here, so it's 3 and 2. This must be a 3, 7 pair. This can't be 3 because 3 in the row, so this is 7. That makes that 3. 7 eliminates 7 here, so it's 6 and 7. We are missing in row 2 a 5 and a 6. So either of those could be 5 or 6. In the rest of this box, we're missing 1, 5, 6, but 1 can't be here. Where is the 1 in this box? It must be here. So this is 1. This has to be 5 or 6. This must be 5, 6, 8, or 9 for the rest of column 2, but it cannot be 5 or 6 here. Therefore, this is 8 and 9. We have an 8, 9, 8, 9 pair in column 2, which eliminates 8 and 9 in the rest of the column. This can't be 8 or 9, so it's 6. This can't be 6, so it's 5, which makes this 6, which makes this 5. This can't be 6 because of the 6 in the row now. Where is the 5 in column 1? These are all filled out. These can't be 5 because of 5 in the box. This can't be 5 because of 5 in the column. This is filled, so we need to have a 5 here. That leaves this as an 8 and 9 pair, which eliminates 8 and 9 in rest of row 7. That leaves 1 and 4 remaining. This can't be 4 because of the 4 in the column, so this is 1, this is 4. We have 6, 8, 9 remaining in the rest of row 9. This can't be 8 because of 8 in the columns, can't be 9 because of 9 in the column. We have in row 1, the remaining digits are 3, 6, and 7. This can't be 3 or 7 because of a 3 or 7 in the column, so this is 6. This can't be 6 or 7 because of the respective 6 or 7 in the row or column, so this is 3, which makes this 7. We have 8 ones. We know where the last one has to be. It has to be here. We should have 8 twos also. Yep, we know where the last 2 has to be. It has to be here. 3s, we have all 9 3s. 4, we have 8. We have 7 4s, but 4 in this right central box cannot be here or here. So 4 must be here, which means this is 7, which makes that 4. 7 eliminates 7 here. So it's 9, which means this can't be 9. This is 8, which makes that 7. This 9 eliminates 9 here, so it's 8 and 9. So yeah, we should have all the 4s. We have all the 5s. We should have... This 6 eliminates 6 here, so this is 8, which makes this 9, which makes that 6. The 8 eliminates 8 here, so it's 9 and 8. We have 8 6s. We know the last 6 has to be. It has to be here. 7s are all done. 8s we're missing. We have 8 8s. We know where the last 8 has to be, and we know where the last 9 has to be. So that's a 9. And that's how you solve it. Yeah, index lines are kind of interesting because it forms a unique restriction on the index lines. You can only have, in normal Sudoku, you can only have one digit of each digit of the length from 1 to the length of the line on the index line. If you ever run into Schrodinger's with index lines, that complicates things a lot. So, but normal index lines, you have to have 1 through that digit on the index lines because of the logic that we showed before. And then combining the index lines with the region sum lines makes this rather easy to solve because you just have to know what the sum of the index lines from 1 to however the length is. So for example, this is 1 through 5, so that must be, the total sum must be 15. So each segment is divided, there's 3 segments because the box borders divides the line into 3 segments. So 15 divided by 3 is therefore 5. And you can do that similarly across all the other lines, but not necessarily on normal index lines. So anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.